I think it's good to start. Good day, everyone. Welcome to this Observation Coordination Group webinar series. Today, we are going to talk about monitoring the performance of voluntary observing ships and also the data buoy cooperation panel platforms. I'm Champika Gallage. I'm a scientific officer on ocean observations, working at the WMO Infrastructure Department here in Geneva, Switzerland. So in this webinar, it will be for 90 minutes. And we will talk about the monitoring the performance of these platforms, voluntary observing ships and data buoys. And as we all know, most of these platforms almost all the time stay at the sea, and it is not always possible to check the physical condition of this equipment. So for this reason, there are several tools available for the operational people to use to check the performance of these platforms. So we are going to talk about this during these 1.5 hours. And we have 5 different small little presentations done by experts in the field. And after that, we will have some time for questions. Throughout the presentations, if you have any questions, you can put your questions at Q&A section of the webinar. And I am sure most of you are already familiar with this kind of webinars, and you know where to find the tool to put your question there. And we will try to answer as many of them as possible. And if we cannot answer any of those, we will be able to communicate with you through email if you put your email down in the question to give you more details later on. So without further ado, I first would like to invite Joel Cabri. He is currently the manager of the Marine Observing Networks for Australian Bureau of Meteorology, and he is also the chair of the Voluntary Observing Ships panel and chair of the SOT, Ship Observations Team Task Team for Recruitment, Promotion, and Training. On top of that, he is also an executive board member of the Data Buoy Cooperation panel. So I'll ask Joel to give an introduction of this session, please. Thank you.
Thanks, Champika, and welcome everyone. We really appreciate you all taking time to join us to discuss this important topic. And hopefully everyone can learn some useful tools to help ensure that all the marine data that we're collecting is of the highest quality. I'm hoping everyone can see the presentation. So I wanted to sort of start the session with a few questions for people to ponder while we work through the presentation. So just things I'd like you to be thinking of during the session is, why is data quality important? How can we monitor data quality for VOS and for DBCP platforms, so drifting buoys primarily and moored buoys, and who is responsible for taking up follow-up actions to correct any deficiencies with the quality of the data? And finally, where can you go to get some help with improving the data quality for your networks? So if you can keep these questions in mind as we work through, and then we can address those towards the end of the session. So first of all, we're going to go to a pre-recorded video from Darren Figursky. So I'll hand back over briefly to Champika to introduce Darren, and I'll get the video ready. Thank you.
Thanks, Joel. So the very first one is a recorded presentation, and if any of you cannot see the recorded version, please put a note in the chat, and we will be able to share the link to that for you to stream on your side. So Darren is the operations branch chief at the Ocean Prediction Center at NOAA, USA, and he was also the former chair of the ship observations team, and currently he is chairing the SOT task team for expansion of independent class observations. So let's listen to Darren now.
Was National Weather Service and the Ocean Prediction Center. I'm also the past chair of the Ship Observations Team and the current chair of the task team of expansion of independent class observations. I'm glad to be here with you today to talk a little bit about the importance of observations. And I wanted to note that as a marine forecasting unit, myself and other forecasters who are forecasting the weather 24/7, 365, really rely on observations to help us understand the weather features and the hazards that might be associated with those weather features out over the high seas. On this slide is an example of a surface analysis on the left over the Pacific Ocean from February of 2024. And on the right is a wind wave analysis showing especially the feet of the waves out over the Eastern Pacific, in this case at 12Z on February the 5th. When we start to produce these, due to the lack of observations, we may start with some computer model guidance and a few observations that we have to get a sense of where the lows are, where the highs are, where the cold fronts are, the warm fronts are, how high the waves are, and so on out in the open ocean. But when we get an observation, we change what's on those analyses to make them fit the observations. So for example, we want to make sure that the winds ahead of a front make sense. In this case, we want the winds to be generally southwest of a cold front, northwest behind it, which is typically what would happen. So we'll adjust the positions of fronts, we'll adjust the positions of isobars, we'll add to the values of the seas to make sure that everything that we have on these maps is as accurate as possible. And the observations also support the worded forecasts that we do, such as high seas forecasts, offshore forecasts that are provided to marine customers, and so on. Here's an example of observations superimposed over a visible satellite imagery at 17 UTC on February 5th. In this case, this is over the Western Atlantic, just off the coast of the Eastern United States. And while it might be a little bit difficult to see, one thing you can notice, all the green dots over land, and the sparsity of those dots over the ocean, indicative of many more observations over land, obviously, than we have over the water. In yellow, we have a stationary front here located off the Carolina coast. And there's an observation which shows a northeast wind of 45 from 45 degrees at 17, gusting to 17 knots, a southeast wind on the east side of that front with gusts to 25 knots. And having those observations there can really help us place that frontal feature in the right place. There's an observation, well, there wasn't an observation here, but on satellite imagery, you can see the circular appearance of the clouds where there was a low pressure center. And I want to focus on the circle here, which in this northwest flow on the west side of the low, it has a lot of cold air. And it would be great to know if we had observations. Now, satellites can help. Some people may say, well, you have a lot of satellite imagery. Doesn't that take the place of having, like, say, ship reports or buoy reports? And really not. And I'll show that on the next slide. But the one thing I want to mention on this slide too is, in addition to the winds and the seas and the pressure and the temperature, we want to actually know in the wave heights. We also have some of these manual things, such as whether it's raining or is it foggy or is it freezing spray. Those things are very important. And one day I was working a shift and I got a report of rain from a vessel. And radars coming off the land, they can only see so far very well until the radar beam gets so high that it's difficult to tell whether it's raining or not underneath. And with that report of rain, I had added some rain showers to my forecast, and getting the report actually confirmed the forecast that I updated was very important. I sent a note to a port meteorological officer to relay to that vessel, thanking those for taking that report to get it to us, because again, it helped to verify the forecast. Now, getting to the point that I wanted to make in the circle. Here's a circle from showing a gap in scatterometer imagery that we get from satellite. Now, the scatterometer imagery, as well as altimetry that we get, which shows the wave heights out over the open ocean from satellite, those are taken by polar orbiters. And those kind of go around the globe from the poles, and they tend to come in strips. So in between the strips, there'll be gaps. And in this case, while we have some satellite imagery here, showing the winds, the wind direction, as well as wind speed. So the yellows in this case would represent gales, the greens more like 20 to 30 knots, the blues less than 20 knots, the whites are probably like less than 10 or 5 knots, and so on. But there's still a big gap in between where the polar orbiters go. And so while satellites definitely help, they help us, we really need the observations for ground truth. We also need the observations in between the gaps, again, to validate what's going on, to help us where there aren't any satellite observations. So observations definitely can fill in the gaps. And here's an example of how, some of the observations that we get can be really, really important, have a really big benefit onto our forecasts and then the decisions that mariners make out over the open ocean. So with the observations that we get, they all go into the computer models. They help make the computer models more accurate. They also help the forecaster understand what's going on in the open ocean and help us to make the products that hopefully translate, the accuracy of the features to the mariner, again, so they can make good decisions. On the left, we have scatterometer imagery. This is over the Gulf of Alaska and off the northwest coast of the United States. The hotter the colors, the stronger the wind. And over the southern Gulf of Alaska, you can see around the low, which is right there in the circular appearance, these hot colors, especially the bright red, represent hurricane force conditions at that time, late on September 30th, early on October 1st of 2024. On the lower right are some 96-hour forecasts, which with good computer model guidance, good observations going into the guidance, we were able to forecast well in advance, out to 4 or 5 days, the developing hurricane force and a hurricane force low moving into and over the Gulf of Alaska. And then you have the upper right image, which shows a lot of vessel avoidance in the Gulf of Alaska at that time. So getting the observations from a vessel, as well as from satellite, but certainly from vessels, to get into computer model guidance, to help the model guidance get better, to help us provide better forecasts, which then in turn helps critical decision makers, people, masters of vessels, vessel captains, routers, and so on, make good decisions to avoid the bad stuff. This is exactly what we want, and the observations are needed to be able to do all of that. Here's another example, a little bit more recent, from late December of 2024. In this case, this is December 21st of 2024, just before 6Z. And this is an image of waves. And so the waves are in meters, so you might have the lighter blues, 4 meters, you get into the darker blues at 9 meters and 14 meters and so on. And the waves were pretty high over the Pacific at this point, because there were several, like a train of really, really strong lows going on from west to east across the Pacific Ocean at this time. Again, with good model guidance, with good observations going into that model guidance, and good forecasts by folks like our, at the Ocean Prediction Center, forecasters there, we certainly, I believe, helped the critical decision makers out over the open ocean make good decisions to avoid, again, the really, really bad stuff. And it's not perfect. You'll notice a few of the vessels in the triangles, getting into some places where it must have been pretty harrowing out there with some pretty high seas. But nevertheless, many, many vessels went a different way. Maybe they held in place for a while based on everything that we were able to do, starting from observations. People were able to make largely very good decisions to avoid some really bad things. And here's an example of how bad things really got out there. So on the left side, this is December 21st of 2024, just about an hour before the last image at 420Z. This was roughly 20-meter seas, actually seas of about almost 66 feet from this strip of altimeter imagery out over the open Pacific at that time. If you look at the lower right, though, that strip to the left is where the middle of those near 66 foot or near 20-meter seas occurred, which is right about here. You'll notice it's on the left side of the low pressure, which is located just to the east. Is it possible that the seas were a little bit higher? Could be possible. We wouldn't want reports, hopefully, of that, but if there was somebody there, unfortunately, we want to get that report so we would understand what's going on. And regardless of where a vessel was in this entire regime, Having the reports there would be very, very helpful to understand the locations of any fronts, the locations of seas in between the scatterometry passes and the altimeter passes, and so on. So again, very, very helpful to get those observations. This is an example in the tropics. So I've talked a little bit about the extratropics, kind of the maybe a little bit farther northern latitudes in the Pacific and the Atlantic. But certainly in the tropics, the observations are just as critical, sometimes even more so. And in this case, you see Hurricane Milton on October 9th of 2024. The representation of the wind field is on the right side of the screen, getting ready to head into the U.S. state of Florida. Moving over the Gulf, though, you can see on the west side of the Gulf, there are a lot of ships kind of holding into place, haven't changed their trajectory a little bit. A lot of great avoidance on the right side. Just another example of kind of the end-to-end process where the observations help the guides, help the forecasters, make better forecasts, which in turn then help the critical decision makers and the vessel masters and the routers make better decisions. In this case, Hurricane Milton had winds of 125 knots, gusting to 150. And it's great that the avoidance was so complete and so vast in this case. Here's an example, though, where there wasn't good avoidance. And this is from Ernesto. And this is from August 16th of 2024, where Ernesto was just off the coast of the U.S. at this time. The east coast of the U.S. is of the upper left of the screen. I think it's the Carolinas over here. And there was a vessel that had left and was going south. And we surmise wanted to get around Ernesto to get to its port just in time. Well, as it goes, of course, the tropical system gets closer, the winds get stronger, the waves get higher, the ship more than likely slows down, and it got itself into a very bad way. In this case, a little green spot right there, where looking at some vessel traffic information, the ship probably was carried about 40 miles to the northeast before the storm finally got away and the ship was then able to maintain its course to the southeast. It had to be a very, very difficult ride at that point. It might have been pretty dangerous. We tried to reach out to the vessel, hopes that it was okay. We never heard back, but some of our port meteorological officers here in the U.S. mentioned that they had a documented ship visit in October 2014. The vessel didn't want to participate in the program. And so, by not participating in the program, the vessel, probably maybe wasn't aware of the weather as it should be, maybe had a little bit less of weather situational awareness. And so taking observations is important for that. And if you don't believe me, you can maybe believe the U.S. National Transportation Safety Board, which did a report following the unfortunate incident of the sinking of the U.S. cargo vessel El Faro in the Atlantic, northeast of the Bahamas on October 1st of 2015. And in that report, it was mentioned explicitly that ships providing a continuous stream of real-time marine data would enhance both awareness of current conditions and forecasting. And so in this case, the NTSB really believes that, that taking observations doesn't just help the forecasting and help other folks around them, but it also helps increase situational awareness of the weather on a vessel itself. And I have just a couple more slides, wanted to show, a couple examples of where observations are really critical. And in this case, this is back from 2015, July 29th of 2015. This is out over the North Atlantic. Nova Scotia is to the far northwest part of the upper left part of the screen. There's a low pressure here on a satellite imagery with a strong front going from north to south to the east of the low. There's an example of an observation here, which would be difficult to see, but this is a northwest wind of 65 knots around the low. At this time, our forecasters at the Ocean Prediction Center had storm warnings up. We did not have hurricane force wind warnings. I think we have storms, upwards of maybe 55 or 60 knots, but we did not have the hurricane force wind warning in effect for 65 knots or greater. Once we got this observation, we were able to update the forecast really, really quickly to a hurricane force wind warning. And while for this vessel, it certainly was a little bit too late to get notification, for a lot of these other vessels out here that you can see in the green, I'm certain that even though the lead time might have been short, having that forecast updated and become available could have helped some make some critical decisions pretty quickly. And you might think to yourself, well, this is about a decade ago. Certainly the forecasts have improved since then. And they have to some degree, even to a big degree, but they're still not perfect. And here's an example of a more recent image. This is over the northern Gulf of Alaska when I was working a forecast shift back in September of 2024 on 12Z on the 12th. And this is the northern Gulf of Alaska. And you can see some observations. Again, they may be difficult. This was a easterly wind, maybe an east-southeast wind gusting to 30 knots. But right to the east of that, there were a couple observations in the storm force area right through here. I think in the blue, there's one from 60 knots. And so I made a call to my counterpart, other forecasters at the Anchorage office, and asked them about the validity of the observation. And they took a check, and sure enough, the observations were from a cruise ship that frequents the area. And they said, this is a really reliable one. So what I was able to do is update my forecast for storm force conditions from a low pressure system that was moving north through the Gulf of Alaska. And sometimes if they're just a little bit stronger than you think in the geographic pinch as the system goes from water to land, you can get some rapidly increasing winds right along and near the coastline. So in this case, without that vessel, we wouldn't have known. And while it was, again, short fuse, maybe for some of these other ships nearby, certainly for people on land, that could have been a very important data point to have. So the last thing I'll mention, from a global observation standpoint, the more observations that we have, the better that there are. This is a map globally taken from OceanOPS, and we appreciate OceanOPS every day. But this shows, just from pressure, the number of observations taken around the globe in this snapshot, and the reds would signify not very many. And even where there are blues and greens, that could mean quite a few relative to the rest of the globe. But even in the blues, that could be as few as in a grid point, 1 per grid point per month. So the weather is dynamic, and whether it's blue or where it's green, know that the weather changes, and having observations as frequently as we can help just increase the knowledge of the weather, the knowledge of our climate, the knowledge of our oceans, can support other vessels around, can help overall decision making for better forecasts, and for good avoidance by the vessels out in a very vulnerable situation that can occur out over the open ocean. So thanks for the time and the attention today. I really appreciate it, and wish you well in your workshop.
Okay, now our second presentation is from Joel about the WMO data quality monitoring system. Over to you, Joel.
Thank you, Champika. Sorry, I'll just get the presentation back and running. So yes, thank you, Champika. So we sort of set the scene. Darren's given us a clear picture of the value of ocean observations and why the quality of those observations needs to be of a very high standard for not only for the forecast models, but for the forecasters for that real-time situational awareness. So one of the first tools I would like to share with you is the WIGOS data quality monitoring system, so otherwise known as WDQMS. So it's a web tool resource developed by WMO, hosted by ECMWF for monitoring performance of all WIGOS observing components, which is now including our marine observations, so ships and buoys. There are some links on the slide here, and we will share this presentation with you after the meeting. Sorry, bear with me. So I'm going to give you a real-time demonstration. So I'm opening the tool. So hopefully you can see my screen. And it shows you a plot of all the data available on the GTS for the can choose the time period here from the drop-down list, so either 6 hourly or for the daily representation. And there are different variables, so surface pressure or winds. So for these purposes, we'll look at surface pressure. So we have dots for all the observations. On the right-hand side, you can see icons for buoys and ships. So I can either have both displayed on the map at the same time, or if I click on ships, I can remove the ships and just have the buoys, or vice versa, just display the ships. So it's quite good depending on what you're trying to look at. You can narrow it down, and also with I'll zoom in a bit. We're looking around Australia at the moment. There's not a whole lot of ships in the area at the moment. In the past 6 hours, I might change to daily for a better view. And the key to the bottom left of the map gives you the quality of the data. So dark green is very good. It's less than 0.5 hectopascals when comparing the model to the observation to the model. And by clicking on these, I don't really need to know about the good quality ones, so I might remove those and have a look at some of the less lower quality observations in the area. So this red one here to the north of Australia is looking concerning. So I can scroll in, and you can click on the dot, and you can get some information about where that's coming from. So this is a ship. The identifier for the GTS is here. If I were to copy that, what I would often do is compare it to, I'll drill into OceanOPS, which there's another link in the slide for OceanOPS if you're not familiar. That's the repository for all the metadata for our ships and buoys globally. And if I searched for that identifier, I can find out a bit more detail. So this ship is Green Pioneer. It's part of the Japanese VOS fleet. Been reporting quite well since January 2020. And mostly, you can see along here, mostly green, looking pretty good. We can find out a bit more across the tabs about the issues. There's a data quality issue flagged it's been blacklisted for air pressure. And if we could drill into that, some of the other tools we'll show you a bit later. We'll show you the plots. So here's a bit of a plot showing you the observations, which looks like they're pretty much reporting the same pressure at every observation, which seems a bit strange. So perhaps you could identify that there's a fault with the barometer and it's stuck in one position, an old aneroid barometer with an issue. So it's some of the things you can do with this tool. I'll zoom back out again. Yeah, so it's quite a useful tool just to get a snapshot. Most of the other tools we'll look at are very good for monitoring your own networks, but this can give you a good view of other ships or buoys around your area of interest, and perhaps you can use it to reach out to the operators of those networks and inform them that, in this case, I might contact the port met officer in Japan and say, this ship is passing through. I noticed there's an issue with its barometer. It's going to be calling to an Australian port shortly. Perhaps we could help you out and go and visit and do a performance check while the ship is in our area. So it's definitely a very useful tool in that regard. So I'm not going to spend too much time on this tool. I encourage everyone to use the links in the presentation. Go and have a play. You can't break it. Go and have a play and check out all the functions within the tool. It's very, very useful. Sorry, I've just lost my position. So the links for WDQMS can be seen here on the slide, and the link to OceanOPS if you're not familiar. So the next tool we'll be presenting will be the eSurfMar Marine Observation Monitoring Quality Control Tools. So there's a whole suite of tools here. But before we get into the demonstration of how to use these tools, I thought I'd just give a bit of an overview of how they are configured. So they, likewise with the WDQMS that we just looked at, these tools compare the observations with the models and provide you with some information about gross errors, standard deviations, root mean square or bias. So these are statistical tools to identify if there's an issue with your observations. So there's a few definitions there. Often the main one I would use on a day-to-day basis would just be to looking mostly at gross errors to see if there's a recurring issue, and then maybe at the bias, looking at the difference between the actual and the actual observed value versus the expected value from the model. And within the tools, there are some thresholds set for each different parameter. So you can see in this table here, for pressure, if there's a difference greater than 1.2 hectopascals bias, it will flag it and be put on a blacklist. And so these tools will show you issues with the quality of the different parameters observed by your ships or your buoys. Excuse me. So I will hand over to Sebastian. So Jampika, please introduce Sebastian, and he'll give you a talk on or a demonstration of these tools.
Thank you, Joel. This will be helpful to understand the next couple of presentations. So our next presentation is on the quality control tools for data buoys. And Sebastian Pierre will make that presentation. So Sebastian works at the Meteo France, and he is in charge of buoy network quality control for Meteo France in Indian Ocean, as well as European program eSurfMar, and also the Trusted Global Project. So he will go through the quality control tools for buoys now. Over to you, Sebastian.
Thank you, Jampika. I will share my screen. Is it okay? Okay, hello all. I will present here during a few minutes the way we try to keep a healthy drifter network. First, to keep a healthy and efficient drifting network, choose the good deployment target is a good base to set a network, and then monitoring will be the guarant of data quality. Let's start with deployment policy. So to maintain the network, we got to have a special strategy and adjust our deployment to the drop on the net gain, yes, and avoid, of course, early grounding to expand the life expectancy of our buoys. So for this, I use 3 global tools. The first one is from OceanOPS, is a density drifting buoys map, which shows the gap, the hole in the of data over the world. The second tool I use is from AOML. It's a deployment value map, a KMZ file used on Google Earth, for example. And it's a mix between the lack of data and the life expectancy of the buoys. So it shows the best area in blue, were deployed buoys here in North Indian Ocean. And the last tool for me is Copernicus Ocean Visual Tools, the expert mode. Here it's a Vision Tools suite, and here you have a surface ocean current analysis, and you can have it through many years. So you can see during El Nino phase or other season. It's very useful. So now the buoy have been deployed. Let's do monitoring with first detect anomalies, schedule control weekly and monthly, and apply corrective action. For all these monitoring, I can use QC Tools here with the address. And what to say, it's a very simple and ergonomic tool. The first part here, I would say, is a blacklist. Different parts. The other is a monthly stats here, and to finish the daily data, I will present all these tools. So first, QC tool blacklist. Let's begin with blacklist synthesis, which allows to have a CSV file and then process directly on the buoys. And you can use the website page, of course. If you click on the WMO identifier, you have a link to the control panel page. This control panel page is made especially for VOS, but is also mainly available for buoys, drifter, or moored, of course. On this page, you got monthly statistic on array, plot with monthly statistic, data plot, quality control plots, so compared to models, with the different parameters. Let's see a live example. Oh my God, the first one, 13622, it's a Easterfar buoy. So what's the problem? If I click on the first button, I have all the statistics on the last month with European model and French model, the number of observation, the gross error, which are the error more than 10 HPA, the bias, standard deviation, and root mean square. If I click on data, of course, the data on the 30 last days, on comparison, the comparisons on these 30 last days with the model. Here, it's a European model. I can have access also to the nearest data around my suspicious buoy and the trajectory of the buoy. With all this, I can check what is the anomaly and if I have to turn off my buoy. Another blacklist is a SST blacklist. Here, combined with ashore blacklist, a buoy gone ashore on Dominican Republic. And you can see, of course, the SST going bad. Another sample, a buoy near Greenland, leaving sea ice, and then meet the sea, and we've got a correct sea surface temperature. Now let's see the monthly stats. So this is a page of monthly stats, the different results explained on the bottom. You've got two ways to use it. You can use one buoy. You give only the WMO code here for a buoy or a ship, and you can have on the two last years the stats, the monthly stats with bias, standard deviation and RMS. So here we can follow a buoy which were good until September, and since October it should have been stopped, but it's still on the network. The second way to use this page is to choose a country, and here I chosen India. Statistic from last February. You can see moored buoys, drifting buoys, or ship. You can show all platforms or only platform exceeding threshold. If you choose all, like here, you can see in red the data exceeding threshold. And you have different links on this array. You can click on the number of observation, which brings you to the buoy stat viewed before. And here on the number of the buoy, you've got a link to the control panel viewed before. Last tool I will present to you is daily data plot. Very simple. You get here the WMO ID, the number of days you want, 30 max. The data or comparison you want, so data plot scale to the best scale, and or quality control plot to compare to the model, the parameter you want, or if you want all parameters. These data are updated each day at 12 UTC with the data of the day before. One point is QC Tools available only for platform registered, of course, in OceanOPS. This is an example of data plot for this buoy going bad, and facility to create a direct link on this buoy. Different kind of errors you can find here: degradation of your barometer with standard bias issue. Here, sudden bias after grounding. On this one, intermittent growth error. So the importance to keep survey on buoy or barometer you turn off, because at times they back to a good data. So so very important, just not to only turn it off, but also to keep control on them. And the last gross error due to barrow failure. The more often on this case, they will not come back. Like I said before, very easy to create a link to your platform. In fact, when you see the web page address, it's very simple. Here you've got your WMO ID. Here the type of information you want, so model versus observation, or only observation scaled. The parameters you want, or all parameters, and the period you want. So with this easy link, you can create a link for all your platform on your website, or maybe on an Excel file like you want, and follow all the platform of your network. So these are the tools, how to use them. It's important to have in mind to schedule control. So for our network, we have daily or few days network for deployments, for buoys under survey, so when we have an intermittent issue, and to control also blacklist for sea level pressure. Weekly, I control all blacklists, the date of last data or of last position, to check if a buoy is not ashore or just ended. And also I keep control, as I said, on sensors stopped during 80 days. And of course, check on all stats monthly. Also, a check of presence of drug, not drugs, not the same thing. So now corrective action. I consider I have to turn off sensor when he reports bad data at least 4 days because of intermittent issue. After 4 days, so I can stop the sensor and update metadata for community via OceanOPS. And I keep control on raw data in case of. Also, I apply a DBCP technical document 37 in case of constant bias on sea level pressure. In this case, I put an offset on sea level pressure buffer diffusion on GTS to correct the bias and keep a good information. By the time I have to pay monthly attention to the evolution of the biases if ever it get bad, it get worse. And last, the drug presence detection. On the GTS data, you've got access to submergence, but if you have also raw data, you can have access to time to fail fix GPS information. That is very, I would say, it's very easy when you have both information to be sure you lost the drug of the drifter. So here are the different links I presented. And thank you for your question.
Thank you very much, Sebastian. I can see there are many questions in Q&A, and I ask the presenters to answer as much as you can until we finish the next couple of presentations. So our next presenter is Stefan Steinmoller, and he is the acting manager of Marine Observing Networks for the German Weather Service. And he also works as a PMO, Port Meteorological Officers. He in SOT community, he is the vice chair of the Ship Observations Team, Task Team for Recruitment, Promotion and Training. So he is going to give us the information on the QC tools for voluntary observing ships. Over to you, Stefan.
Thank you, Champika. Sebastian, could you please stop sharing your screen? Okay, thank you. One moment, please. We have it. Sorry, one moment. Okay. Okay, I want to talk a little bit about the QC for VOS stations with the help of the ESERVMA Marine Observations Monitoring Quality Control Tools, short QC tools. Again, the main page and how you can access it above this link, and I marked this in the green border, is a part I want to talk a little bit about it today. If you press the VOS pressure SERVMA link, you will receive the white window where the last 40 vessels with the highest pressure deviation are listed with the different SOT or call sign IDs on the first row, what the vessel name is, and which WOS nation is responsible for it. Also the last incoming report where was the ops taken, and then also the made ops in the last months, and the gross bias and errors afterwards. Then, like with the buoys, you have some options with the little colored dots, which Sebastian already showed a little bit about it. If you want to find a station which is not in the blacklist, more or less, you can also click this WOS indiv control panels, which brings you then to this page. And here you can also jump really fast around to your known stations if you just change the last letters from here in SOT ID to your known call sign or to your known SOT ID, and then you will receive always this actual page where all the main information which you need or which I need are displayed. Yes, Sebastian already talked about it a little bit, more or less the same like with the buoys. You have the monthly statistics, the monthly plots, the data plots, the ops counter, then for this station you entered in your address. Here I want now to talk a little bit about the quality control plots. You can open it with these links for the different parameters which were measured on board of this vessel or from the station, from the pressure, temperature, wind, humidity, water temperature, or waves. And if you click one of these links, you will get to the next page and receive such a little nice graph where you can see the made data plots and how they correspond against the model. There could be a lot of different reasons why such a data plot line is not on the zero line, which represents a very good value. This could be a faulty barometer. So again, I just talk about the pressure more or less, and if you want to test wind, temperature, etc., it has some other reasons why a value could not be on the zero line, but I concentrate more or less on the pressure values. Maybe the door was not opened on the bridge when the value was wet. It's often corresponds to higher barometer reading because the bridge is pressurized through the AC unit, or the barometer reading was not at the same time, or it's actual time made, or the ship position was entered incorrectly. Also, the turbo time could be entered wrong, which then results in a false value. Maybe also the observer reads the barometer incorrectly, or an additional high correction was applied. There are many reasons which can happen, and more or less also it can happen that the analysis is incorrect for a specific date. Like you see here, a lot of values are on the zero line, which presents a very good value, and some are good 5 hectopascal lower. And the first guess, which I would then have, is that an actual duplicate high correction was applied, and you have then get in contact with the vessel, with the crew, inform them about what you have seen. You can also print these plot and give it to the vessel. Also, it's always very good that they can see what happened there, that they understand the problem. And what we really want to see is with our automatic weather stations that a lot of the values are around the zero line, which represents a very good value what we have, and on the right side what we can sometimes encounter, a lot of values which jumps up around, goes up and down. You are then in contact with the vessels, you added a high correction, you check the settings of the software, and sometimes always the values are not correct. Then indicates a very faulty barometer, and the best thing is to replace it as quickly as possible. Here are another examples. Again, a lot of these high correction errors, which happens quite often, what we can discover. Here on the left side could also be a high correction error, but also maybe the barometer is faulty and needs to be recalibrated or replaced. You always have to get in contact with the vessel to find out more and inform them and ask about the actual status, what is on board. On the right side, also one of our WIGOS stations or automatic weather stations where the pressure reports were very good. And in the last 2 weeks, the pressure jumped really up a little bit, and the values are not again on the zero line. At the moment, we are not really sure what is happening there. We will observe it a little bit more and probably have to deactivate the sensor and replace the sensor then the next time the vessel comes to one of our harbors. Another example would just be some outliers, which you can sometimes see in these plots that you see here. We know for the last made report that it was made with the wrong position. It was then more or less a vessel in Africa, so we know, a vessel should not be on a continent. So the made observation and the made or inserted pressure is not corresponds not with the correct position, and so with this we have the wrong flag. Another note could also be if the vessel is on the water that the barometer was not read correctly, or the nautical officer inserted the wrong value into turbowin. More or less I talked already about it. The real work starts then. If you see such problems in the QC tools, then you have to get in contact with the vessel per email, or at the next time the vessel comes to one of your harbors, and inform them about the status. Often it's sufficient if you talk with the crew about it. Sometimes also it's necessary to determine a correction value for the barometer. I added a little screenshot how it looks from our side. So you then ask the crew when they enter the next time they enter a port about the necessary values. You check them against the next official weather station or airport, and then can provide such a barometer check certificate. Afterwards, stay in contact with the vessel and update them with a new plot if then the value is good or not, and decide then if you have to take another action like replacing the barometer. Another option and functionality is these generate automatically the observation monitoring report for VOS. When you click this link, another window pop open where you can choose different options which you want to have displayed in this report. Choose what you like, what you don't like. You can also insert your national logo, press confirm, and after a couple of seconds the report is ready to download, which you then can give out to the vessel or when you visit the vessel. Okay, thank you very much. Any questions from your side?
Thank you, Stefan. Let's go to our last speaker. The last presentation is about the OceanOPS Quality Control Relay tool. This presentation will be given by Martin Kramp. Martin is one of the technical coordinators from the OceanOPS, which is the joint WMO-IOC Center for Ocean Observing System Monitoring and Coordination. In particular, Martin provides the coordination and technical support to the data buoy cooperation panel and as well as the ship observation team communities. So he will speak about the OceanOPS QC tools now. Over to you, Martin.
Thank you, Champika, and nice to see so many familiar names here in the list of spectators, old and new names. So we have a couple of roles for the Goose, and Champika mentioned some of them. We do the implementation support and monitoring. We allocate all the WMO IDs and SOT IDs for WOS, and we are the Goose metadata repository for, at the moment, around 8,000 or so stations at sea. And that is important because from our database, the metadata flow into the WMO OSCAR system, which is again connected to the WDQMS, and that will be of growing importance in the future. Data without metadata is, it loses most of its value. This is why I want to stress this a bit here today. And to make this metadata flow happen, we need at least a minimum set of metadata, including the sensor information. For if you query the OceanOPS website or OSCAR and you do not find a station there, then if it's not in OceanOPS, obviously it cannot be in OSCAR. And if we don't have appropriate metadata, we don't push it into OSCAR. What I want to show you here today is how you can benefit from a tool that has been developed by OceanOPS to, if you are an operator of such instrumentation, how you can be automatically alerted that something is wrong with your instrumentation through the blacklist we just saw, and how other data users can also provide you with feedback if they identify any issues without necessarily having your instrument on a blacklist. So my colleagues already nicely prepared the ground for me. Thank you for that. We spoke a bit about OceanOPS. What you see here on this screenshot is a typical, main page for an instrument in OceanOPS. In the red circle, you see this is, so if you will, the start page, and you have a couple of tabs here, and I will go through some of them. Now, for this, what we see here, it's a drifter from scripts, where we have some metadata, but not enough metadata, actually, in this case, to push that instrument into OSCAR. Next slide, please. So the tab on the right about the operator gives you some information about the program. And in this context here, most importantly, it lists some contacts. And what we do with the QC Relay tool, and I will show you that on the following slides, is we use that information to provide that feedback. So it's important that when you operate such instruments, that this contact information are really up to date in our database. Next slide, please. So you've already seen this here. There was a question from the chat, I think from Mike, who wanted to know how exactly, what makes a station pop up on the blacklist. You see here in green, actually, the definition why the station was blacklisted. If you click onto those dots, you will even find more information with values, and so why the station was blacklisted. So if we in OceanOPS see a station pop up here on this list, next slide, please, we will, based on the contact information we have, send an automated email to the operator of the instrument. In this case here, it was a scripts drifter. You see all those people that were listed, which is the case for the DBCP and SOT. It's more specific, actually. You receive a notification that your instrument is on a blacklist, and you receive 3 links further down. The first link will lead you to this synthesis page in the QC tools, and the other 2 links I will present now. Next slide, please. So if you click on the second one, then this QC tab for that instrument opens in OceanOPS, and you see the different QC cases we had over the lifetime of the instrument. So in this case here, which I show here, is a location issue. And what you can do now, either, next slide, please. Either you click here on this reply button as the owner of the instrument, and then you can provide feedback, say if the problem was fixed, and some more background information, or you would click on the third link from that email. That will do exactly the same thing. What you can also do, if you are not the owner, but just some data user, next slide, please. You can click here on this new feedback button. So regardless if the instrument is on a blacklist or not, if you identify any data issues, you click here, and this will generate the frame on the right, which will be a message to the operator where you can say which kind of issue you identified. And then again, it will create an email as you just saw earlier. Next slide, please. Going back to the WDQMS, if you click on any of those dots here, and this brings us back to the metadata, you see there is also a link to the OSCA system. This will only work if we have metadata for your instrument or for this instrument in OSCA. And let's say it works. If you go to the next slide, please. Then in this case here, it would work for this instrument here, which is a drifter from the Trusted project. It will bring you then the suite of metadata which was pushed from Meteo France into OceanOPS, and from OceanOPS into OSCA, and from OSCA, the WDQMS again will use this data. So if on the next slide, I will just scroll down. This is just a screenshot. Next slide, please. Further down here, you will then see just the metadata we provided, including here the sensor information. Just at the bottom of this page here, it would be the sea surface temperature, instrument, the model, and the serial number, and so on. Next slide, please. So this was the end of my part, and going back to Joel.
Thanks, Martin. So that's sort of the end of the main content for our webinar today. So I think I'll revisit those questions we posed at the start of the webinar. So hopefully, through our presentations, we've identified, answered those questions for you. So the first one: why is the data quality important? So we saw that all this data feeds into numerical weather prediction models, and it's critical for improving the skill of these models. And as Darren pointed out, forecasters, it can provide in situ observations, can provide valuable situational awareness for forecasters in otherwise data sparse areas. How to monitor the data remotely. We've seen a few different tools. I really encourage you to get in and use those links. Go and have a play with the tools. As I said earlier, you're not going to break anything. It's really good just to get in there and really test the functionality and see how it works for you. And if you have questions, please reach out to us. We're always willing to help. And who's responsible for following up the actions? So typically, if you're the operator of the buoy or the ship, it falls to you to be monitoring the quality of your data. It's really important to make sure that the quality is good. Otherwise, forecasters and others will lose confidence in using these observations, and it can, rather than improving the skill of forecast, it can have a negative effect. So it's really important. We all need to take responsibility for working together. And as we saw, you can monitor yours. You can, if you notice an issue with someone else's, you can let them know through the tools Martin just showed. We can find other contact details through OceanOPS. And where can you go to get some more help? So we've put in a few emails here. So SOT, the Ship Observations team, has a task team for recruitment, promotion, and training. So Stefan and I are both on that task team. We're always willing to help. We try to run webinars such as this to help teach people how to do things better, some best practices. So there's an email address there for that task team. If you have questions related to the ship observations and data quality, please reach out to us and we'll do our best to answer you. And likewise for DBCP, for data buoys, there's a task team on impact and value, and they should be able to assist with any queries about buoys. So there were quite a few questions and answers in the chat. We've done our best to answer on the fly. So perhaps I'll ask any of the other presenters, were there any key questions you wanted to, from the Q&A that you wanted to bring up and discuss? I think we have about 19 minutes left. And to the participants, sorry, Champika, you please go.
Yeah, there is a question. Okay, yeah, it got answered. That's good. What is the status of OpenGTS for GOOS SOT group? This is regarding data getting into the real data stream, which is GTS, rather, going when they don't have access to their national weather services to get their data into the GTS. So, Joel, or do you have any input to that?
I don't have an answer now, but we can come back.
Yes, I think we can come back because Kevin O'Brien, who was leading the project, we can ask him about that. So whoever has put that question, if you can add your email address, if you are willing to do so, we can get back to that. And Mike, we will make the whole webinar series available, the whole session available through the GOOS website, and I will put the link to that together with it. Darren's presentation will be there as well. If you need Darren's presentation separately, I can provide the link to you as well.
It has also been added to the OceanOPS YouTube channel, I believe.
Okay.
There is a comment that at the recent IMO conference, there would have been a comment that only automatic VOS will be available in the future. I wasn't at the London meeting, but I don't think that's correct. I hope it's not correct, because we will need manual observations. At least when it comes to eye observations, is of very high value and should not disappear. And I don't remember such a statement, so I would just say this is maybe hopefully just a misunderstanding here. Regarding the other question which just popped up on the OpenGTS, and also maybe related to WIS 2.0, that is not so much in the focus of this webinar here today, but you will see on the last slide we invite you to, if you want to join the ship observations team meeting remotely, which will take place in a few weeks' time, and those items will be addressed in the data session.
I also would like to invite the participants to put their comments, not only the questions, in this Q&A, because we would like to hear from you. What other topics would you like to have similar webinars on? And is there any particular area that we presented today that you would like to hear more about? Those will help us to organize such required areas with more details in webinar in the future. So please feel free to put your comments into the Q&A as well.
I could maybe mention that some of the features I showed in OceanOPS are only available to registered users. So if you are not a registered user yet, you can self-register actually. And just let me say that again, we need your metadata. If you have stations in the water and we don't have the metadata yet, it's not rocket science. If you want to learn how it works and you need assistance, please reach out to us. We are happy to assist in such matters.
For Rebecca, we thank you for providing the email address. We will direct your question to the appropriate person and hope you will get the answers from there. And for webinar ideas, we got how to get the industry involved in the VOS, which is one of the big ones that will come in this SOT 13 Ship Observation 13 session. There will be one full session on that. So if you have not registered yet, I highly encourage you to register for the session to participate remotely. Any other questions, comments? Please put them in Q&A and we will wait for another 30 seconds. If there are no any other questions or comments, I would like to thank all the presenters and all the participants to this session. I hope the session was valuable for you to improve your services in day-to-day life. Again, a reminder to register for the 13th session of the ship observation team coming up in a few weeks' time. So hope to at least see you on videos at that session, at least some of you at the SOT 13. Anything else you want to say, speakers, any of you?
Yes.
Okay.
Thank
There
you.
was a
Thank you to everyone for joining.
There was a follow-up regarding this IMO thing. So please keep me in the loop on this one, because some of us, and Steffen, for example, was at the meeting. So on WMO side, we clearly will not exclude manual observations in the future. So I don't know what exactly was said from IMO. IMO will also be at the SOT 13 meeting, but I will happy to clarify here.
I think the question also directs towards the wave measurements from the ships. That's basically the automation question. So I think regardless of whether it is going to be only automated, we also should keep in mind about this question on the wave measurements coming from ships, whether they are automated systems on ships to measure waves and deliver the data. So that may be something that we can bring to the SOT session to discuss further. Okay, looks like we have answered all the questions. Dijana, yeah, please send that information to the presenters. That will help us to continue the discussion on automation of VOS. There's another comment at the last comment. May we get ocean parameters of wave current, SST, atmospheric pressure, significant wave height, and wind speed and direction over the exclusive economic zone of Ghana? Please, it is possible for us to get the bathymetry of sea.
I can probably comment on that one, Champika, if
Yes,
you like.
go ahead.
So we often, we had a port meteorological officers workshop last year in Fiji, and we try to do these periodically to help train National Weather Services to implement some of these networks themselves. So there are opportunities to recruit ships around Ghana and get these observations onto the GTS and increase those, and likewise for buoys. So if you are interested in starting a new VOS, a national VOS program for Ghana, or likewise drifting buoy deployments, reach out to these the presenters or those emails contacts we provided earlier, and we can definitely assist you and provide some guidance on how you can start those steps in the right direction.
Okay, I think that's all. I think we address all the questions. And since there are no any other questions, I would like to close this session. Once again, thank you very, very much for all the speakers, as well as who joined us online to listen to our webinar today. And as I have answered some of the questions here, I put the link to the webinar series on Goose website. So this webinar will be available through that link in a couple of days. So you can access it online after a few days' time. Thank you very much and hope to see you in future webinars.
Thank you.
Bye.